Right, so it's 10:45. Let's get started. This is kind of a long talk, so I'm going to try to move quickly, but hopefully not too quickly. Thank you for coming, everyone. Welcome to Writing, Rewriting, and Rewriting Armello's AI system. I'm Matthew Rowland. A little bit about me. I am the gameplay programmer at League of Geeks. Despite studying game development at uni, I actually come from a web dev background due to the whole industry collapsing a few years ago thing. I like solving problems. That's why I like programming. That's like the crux of why I do it. And web dev was not about solving problems to me. Web dev was about building a really bad jigsaw puzzle out of really bad pieces that don't quite fit together quite right, and you just bang your head against the wall for a long time. So I eventually decided that I should do what I actually wanted to do, which is game dev, which lets me solve puzzles all the time. So we work on a game called Armello. You may have heard of it. We've been at PAX the last couple of years. We'll be there again this weekend. This is the prettiest slide in the whole presentation, so please enjoy it while you can. I am definitely not an artist. So Armello is a digital board game. It's turn-based. It's got hex-based movement. It's got cards. It's got animals. It's got strategy. It's great. And yeah, that is the game that I was challenged with coming up with a new AI system for. So on the technical side, we use Unity 3D. You use C# to make it. It's on PC, Mac, Linux, PlayStation 4, and Xbox One. It's got online multiplayer, peer-to-peer, using a rotating authority system where whoever's turn it is the authoritative client, which will be a little bit relevant later on. The architecture is heavily message-based, so gameplay stuff happens, it sends out a message, and then UI and other gameplay things can update based on that if they want to. And the structure is also inheritance-heavy, which, funnily enough, we inherited from the early days of the project. It's been in development for 5 years now or something that started out part-time, so there's some pretty old decisions that we're still dealing with today. So the AI system that I'm replacing was written by a good friend of mine, Justin, a long time ago, under very different situations than I'm working under now. So the game had been in development for a couple of years already at that point, and the developers were working on it part-time. They still had their day jobs, and so there was a lot of distributed development going on. Lots of different people working on it over the course of a couple of years. They got to the point where they needed workable single player for a Kickstarter demo. So there was a very limited schedule. Money was running out. People needed to get the Kickstarter up and everything. There was no dedicated AI programmer, so it was put onto whoever was willing to take up the task at the time. And it was very early days in terms of the final gameplay features that would be in Armello. So it's very hard to plan for a game that is still got 3 years of development left to happen on it before it'll be feature complete. So within that constraints, the goals of the system were that the hero should have a distinct personality. That's one of the core tenets of Armello, that each hero is very distinct, and you should feel that when playing against them as the AI. The system should be designer-friendly, that it should be able to be implemented and then passed off to a designer to impart that personality and be able to tweak the balance of the AI to make sure they did the right thing at the right time. They should prioritize quests, because that's a simple way to make the AI look like they're progressing towards the end of the game. It's a very granular thing that is easy for the player to see them doing. And most of all, they shouldn't look stupid, because they don't have to be super, super smart, but if they look stupid, then their players are going to lose faith in the abilities of their opponents. So the mechanics that are put in place for the existing system are primarily that the AI have an idea of a meta goal. This is usually tied to whichever victory condition that they're trying to achieve, whether that be combat or there's 4 different victory conditions. Not super important, but it basically informs them of which tile they're trying to get to at any given time. From there, we use a combination of A-star and Dijkstra pathfinding. We assign tiles a score. They use that score to find the variance in the path that will take them to their meta goal tile. There's a friendliness and hostility system to tie into the whole backstabbing board game nature of the game. If you play cooperative cards to an AI hero, then they're more likely to be nice to you. If you play, vice versa. And then card play, which is one of the real sticking points for me in the current system, was really done in the bare minimum, don't look stupid kind of way of like, let's pick a target that if it's a good card, a target that is us or that we're friendly to. If it's a bad card, then pick a target that we're hostile to, and then we'll play it to them without much more consideration of the implications than that. So yeah, mostly random. So this is a screenshot of our AI Slack channel. You can see there it was opened in December 9th, 2014. And then I was added to it in January 29th, 2015, so a couple months later. And then there was no more activity until July 20th, 2016. That's 18 months. That's sort of where it was at. With no dedicated AI programmer, it sort of was not the highest priority compared to getting the game to be feature complete and ready to ship. So that's, yeah, the kind of situation that was in, and that's why that's why the system has not maybe had the love it deserves up until now. So the existing system does have some strengths. It's simple to understand, simple for in terms of like the initial upfront cost of the implementation. It's quick. The AI can do all their planning at the start of their turn and have it done in under a frame very easily. The AI do appear to have purpose. It's totally good enough for making the AI not look stupid and make like they're moving towards a final goal. And yeah, there was a low upfront cost, which was a very important consideration at the time when the system was first developed. It does have some weaknesses though as well, obviously, or else I wouldn't be rewriting it probably. It is difficult and time consuming to support new gameplay features. So by that I mean, because the AI shares very little code with the main gameplay loop, if there's ever a change to a feature or a new feature is put in, then we have to write specific code for the AI to understand that system and know how they should score it. That was fine early days when there weren't that many systems, but the game's grown a lot in the last 3 years, and it's become more and more hard to maintain. Card play has become more of a problem as we've added more and more complex cards to the game. Early on, when the system was first written, they were mostly simple effects like deal damage or add a stat or a resource. Now there are much more complicated effects that are hard for the AI to understand and hard to write custom code for. They don't have support for combinations of cards. They have no real idea of how cards relate to each other. So if they were to be able to use a card to afford another card, they have no idea to do that. If it does happen, then it happens at random, and then you're like, oh, that was clever, but it doesn't happen often enough. And movement and card play are completely separate. So like I said before, they choose card targets pretty much at random. They will play a card at the start of each move if they can, rather than really being intelligent about like trying to play a teleport card that would get them closer to their goal and incorporating that into their movement planning. It's no longer designer friendly. I think it would have been at the start before I joined, but adding all these extra modifiers and switches that we can toggle for all the new gameplay features has ended up with a system that's become quite unwieldy. There are a lot of inconsistent modifiers. It's not entirely clear what value should be changing by how much to achieve the desired result. And it's difficult to debug. If the AI does something stupid like kill themselves, it's not always obvious where you should put your breakpoint, what variables you should be looking at to try and figure out why they did that. So if we were to write a new system, hypothetically speaking, what would the goals of that be? So we need to maintain the hero personality. That's a core tenet of Armello. We should reclaim the designer friendliness so that the designers have empowered to impart that personality upon the heroes. They should have smarter card play for exactly the reasons I was saying before. Let them do the kinds of combos that a human player would do that make them look like they've really got an idea of what they're trying to achieve. We'd want, ideally, automatic coverage of gameplay changes so that if we tweak the value of how valuable a dungeon is, then we don't have to go and tell the AI that a dungeon is more valuable than it was before. We should support difficulty levels, just in case we want it in the future. This is not something that is currently planned, but if we're going to rewrite it anyway, may as well get a quick win out of it, right? And it should be easier to debug. So my solution was to simulate all the things. I know everyone uses that image, but I couldn't resist. To go into a bit more detail than that, the AI should run through as much of the existing gameplay code as possible to get that automatic coverage. We'll boil the entire game state down to a score for each AI. There's a lot of complex systems in Armello, but most of them can be really reduced to like whether the AI has been improved or not improved in their situation by the change in that system. So then we would simulate an action, whether that be movement or card play or something else, compare the score before and after, figures out whether it's good or not, and then compare lots of paths of those different actions and choose the best one to take. So I suggested that to our lead developer at the time, Jason Backer, and he basically said, like, no, don't do that. That's crazy. He said he had a few reasons for that. It was more than just laughing at me. So his objections were primarily that Armello's message-based architecture would make it very difficult to separate the gameplay code from the game state and UI updating code. If we run through the existing code as it is, then we're going to send off messages everywhere. The game's going to update. You're not going to be able to revert it easily. It's going to be very complicated. Exactly that. It's hard to make it designer-friendly. With so many complicated systems in the game, it's going to be real hard for someone to look at all those and figure out which values they should put at where to get the result that you want out of the AI's decision-making. It's going to be slow. It's going to be a lot slower than the current system. They're not going to be able to run it in a frame anymore. There's a lot of code to run through, and if you're doing it over hundreds of tiles and hundreds of cards or potential card targets in a single turn, there's no way that's going to be the acceptable solution. And even if you solve those other three problems, it's going to be a lot of work to refactor and rewrite and solve all these problems. It's going to take a lot of time. So yeah, the idea wouldn't go away though. It kept nagging at me every time I had to update the UI to support update the AI, to support a new feature. I was just like, why am I doing it this way? This system has served its purpose and done really well, but now it's time for it to go. And so I waited until Jason left the company and did it anyway. And I set about trying to solve his objections one by one, because I like solving problems. So see how I tied that back? So yeah, this is what I was just saying. I was falling behind. They were less clever than they used to be. It was becoming very expensive to debug. And if we ever wanted to do really lean into the single player side of Armello, because currently it's like sort of multiplayer first, then we'd really need the AI to be able to stand up to the kind of scrutiny that would put it under. And there's also something I'll get into a bit more later, but there's an engine feature where we have two namespaces, Armello Engine and Armello Unity, that I thought might have maybe set us up for success with this and make my job a bit easier. And of course, anything I learn from doing an AI system here will be experience I can take across to the next project and make that process a bit cleaner and easier. So the first problem I had to solve was scheduling. Log is a small team. Our priorities change often. There's only 12 of us in the studio. It was a lot smaller back when I started this, so I think we were 8 people then. And so it's hard to really block out a contiguous large block of time to work on a big feature if you might have new platforms coming in or new features or new opportunities that you have to take advantage of at short notice. So our solution to that was to split the work into 2 blocks that would be a bit more manageable. The first block would be the structural changes, the refactoring that I needed to do to support the kind of changes that I wanted to do with eliminating messages and game state updates and all that kind of thing. I felt like I had a good understanding of the work that would be required for this, and that therefore I was able to scope it well and do it up front without actually implementing the gameplay changes. So we'd get that running, get all the existing code running on that new base, make sure there's no bugs in that with the new inheritance and stuff, and then come back and do the gameplay later. And ostensibly this would be about half of the total work of the system. This was originally approved in September 2015, which was just after the game came out of early access. I started working on it in December, and I finished that task in January, and it shipped out in version 1.2. So part 2 of the changes would be the actual gameplay logic, changing the AI behavior. I figured it would take about the same amount as part 1, so maybe 3-4 weeks, give or take. It got repeatedly bumped through changing priorities. I heard someone giggle, thank you. Repeatedly bumped, so it missed version 1.3, missed version 1.4, not because it wasn't done, because I wasn't working on it yet. Finally started working on it in June, so we're talking 6 months gap between these two parts of this code. And it's still going, I'm not done yet. I'm giving a talk about it, not done, don't worry about it, it's fine. So around this time, we'd started doing sprints more formally with our new lead developer, and this really forced me to scope out more specifically the tasks that I had remaining, rather than just saying make the AI better, which is what I'd been doing previously. And I quickly realized how naive my initial estimates were of the amount of work that was required here. So the task has just been bumped back to miss the next major update as well, even though I am working on it, but the light is at the end of the tunnel, I can see the end, and that's why I think I'm ready to give a talk about it. So the next problem that Jason had is the message system. My solution is more inheritance. It's already a very inheritance-heavy game. I said, why not lean into that? Just make it better. That'll be fine. So we'll put the gameplay logic into a base class. Then there will be a real subclass that will have all the game state updating messages, the UI stuff, all that kind of fun things that are there at the moment. And then I'll add a new subclass that is the sim subclass that will have all the scoring code, basically. No worries, easy, right? So what would we have to simulate for this to work? So there's the player. The player keeps track of what cards are in your hand, what quest you're up to, stuff like that, stuff that regular creatures don't have. Creatures have like your position, your state in terms of your like combat, all that kind of stuff. Your creature stats, fairly self-explanatory, all your health, your resources, very important stuff to keep track of when you're making decisions. Special statuses are, there's sort of one of those for every gameplay feature. So you got stealth and scout and corruption and stuff like that. So they're just grouped together and under a really generic name for fun times. And then status effects, so your traditional buffs and debuffs, temporary status changes. Those are all the things that I figured I'd have to split into that kind of hierarchy. So I hope you like UML diagrams, because there's going to be a few of them in this next section. Also, if you're a UML purist, I apologize in advance, because they're almost definitely very wrong. So we start with a creature. We add, this is going through the current inheritance hierarchy just to get you up to speed. We got heroes and NPCs can be creatures. There's 3 different kinds of NPCs. We don't really care about them too much today because we're not going to simulate them. They sort of run on a sub-AI kind of coroutine. They have their own rules. Also, I'm using red lines for inheritance. That's definitely not UML standard. I will get to why that is important later. So how do the rest of the gameplay things relate to the creature hierarchy? We've got special statuses. I'm going to put 4 of them on here. There's a lot more than that, but it got very messy if I put more than 4. So, those all do various different gameplay things that are not super important right now. And every creature has 1 each of those. There's also other kinds of special statuses, such as bounty, that only heroes have. So you can see already that there's some hero-specific code that's going to have to deal with that. Every creature has a creature stats, and every creature has a status effect manager, which, funnily enough, manages the status effects. So what does this look like? And then player. There's a player that controls every hero, and that could be an AI player or a human player. Obviously, we're concerned with AI today. So what does this structure look like if we do my inheritance-based sim structure? So I got rid of the NPCs. You don't have to worry about them for today. So we've got to add a base creature and a sim creature. So like I said before, base creature, gameplay code. Creature is game state updating and UI. Sim creature is the scoring. Fine, easy. Of course, there's got to be a sim hero as well to come off the sim creature to handle that hero-specific code. Do the same thing to player. Base player, sim player, very, very self-explanatory. Same thing for creature stats. So a base creature has a base creature stats. I don't know quite how to represent this kind of thing on a UML diagram, but if you're a creature, you've got a creature stats. If you're a sim creature, you've got a sim creature stats, and the base creature has the base creature stats. Sure. Status effects, same thing, sim and base. Status effect manager is going to have to be templated now. It doesn't really care whether it's working on a status effect or a sim status effect, but the creature needs to know. And then special statuses got a bit gnarly. So I decided that the inheritance wasn't really going to work there, so I did an interface instead. And then the interfaces for them derive off that interface. And then there's a sim and a regular one that implement the You can see how this is getting out of hand pretty quickly, right? But that's not even my biggest problem with this. I had sort of said, okay, that's fine. Special statuses are not that complicated. I can deal with that later. I want to look at a much more far-reaching problem first, which is this relatively simple method. I hope you can read that okay. From creature. This is what happens when you unequip a card from your inventory. So there's a few distinct parts here. There's the switch statement, which does a bit of bookkeeping about which items you have equipped. Then there's the if-else if there that determines where the card should go when you unequip it, whether it gets discarded or goes back into your hand. And then there's a message at the bottom that gets sent out to update the UI and a couple other gameplay things that get triggered off of that. So what does that look like if we split it into base creature and creature? Well, you can see intuitively already that it's like twice as long to do the same thing, right? You've got, on the left-hand side is base creature with the gameplay effects. You've got the same switch statement doing the bookkeeping. Then you've got the putting the card back in your hand, because that's something that's important to simulate if you want to know where the card goes to. And then creature doing the other stuff. It's first, you can see, I don't know if you can read the comment, we have to do the same switch statement again just to find out what slot the card was equipped to, which is super gross because there's no good way to determine information in the base class and pass it back up to the subclass. Then we send the message out. Oh, that's a different message. That's fine. Don't worry about that. If we put the card back in the discard pile, we have to do that in the creature, because if we do that in the sim code, then we're going to accidentally put a bunch of cards into the discard pile, which is no good. And then we send out the message to update the UI, and we call the base method in between. So already the code is way harder to read. It's way more complicated. It's less understandable, and it's way more verbose than it needs to be. But there's a bigger problem again, even. So we've got base creature to share creature and sim creature code. But hero and sim hero need to share code as well. And the only class they have in common is base creature. So say we want to affect the hero's bounty. We can't put that code in base creature. We have to put it in hero. So how does sim hero know about that? So I was like, oh, cool, interfaces. I've gone down this path already. Put an interface in between. At least then we can know what methods a hero needs to implement. And if we have a base creature and we know it should be a hero, we can cast an iHero and everything's fine. And it was fine at first because I was just doing that first part of the task. I was doing the big refactor to make this hierarchy a reality. And what I was doing on the sim side was this, just throwing not implemented exceptions if anyone managed to call into sim code, which, it turned out that the gameplay side of the code was working fine. You could call all the right functions, but it wasn't until I came back 6 months later to actually implement the sim side of things that I realized what this problem was. And that's that. So this hero method here, I just chose a simple example. It determines which stat you want to use in combat. And it uses like evade, which is something that only heroes have, so it can't be in creature. And I wanted, it's all gameplay code, right? There's nothing here that updates UI or changes the state of the game. So sim hero needs to do it as well. And this is what the sim hero version 1 looks like. It's the same code with a comment yelling at me to fix this, because I should be able to share this code, right? And again, at the time, just like with the special status interfaces, I convinced myself that this was just something I'd have to live with to get the features that I wanted to get. So I did have to solve the problem, but I would go down a darker road before I got there. So let's talk a bit more about inheritance, and we're not done with UML diagrams yet, I'm afraid. So we got some problems, obviously. Complex inheritance hierarchies, special statuses especially are a mess. We've got template classes, which are usually a bit of a gross thing unless you really, really need them. And we can't share code between hero and sim hero, but I decided there were acceptable trade-offs at the time. So I decided to push ahead with simulating the next part of that big diagram, which I decided to go for the status effect manager next. The problem was that in the intervening 6 months, we'd added a lot of features and the status effect system had expanded considerably. Instead of having this very nice, simple hierarchy of a manager with status effects, we had something more like this. Tiles and perils also now had status effects. There was now a new class of status effect called pacts that existed only between 2 heroes, and so there was a new pact manager to handle that. And so, let's have a look at what that would look like if we did the whole sim base class hierarchy. I'm kidding, I'm not going to do that to you, I'm sorry. Also, I didn't want to make the diagram. But it was pretty obvious to me straight away that the same approach was not going to work. And that's why, I never even got to the point of trying to implement that. So I started thinking about, okay, inheritance is not going to work there. How can I share this code in a smarter way? And I sort of half implemented something like this. The actual implementation is lost to time because it never made it into Git, luckily, for my own sanity probably. But I will try to give a brief explanation of what is going on here. My idea was basically that you'd have a status effect manager class that was double templated, T and U. It would have a manager that would determine what kind of manager it was. And it would have either status effects or pact effects in it, based on whether it was for the hero or for the creature tile peril thing. So that's what these 4 boxes in the corners are, is my attempt to represent template classes on a UML diagram. I'm sorry, everyone. And Yeah, I sort of got halfway through this, and again, all the way through, I was convincing myself, this is fine, this is an acceptable trade-off. I can keep this complexity contained and just make a nice API into it, and it won't be so bad. No one's going to have to deal with this except me. And, you know, there are a bunch of problems with it, obviously. Look at it, it's a mess. And I sort of realized eventually that what I was really trying to do here had been staring me in the face all along. I use Unity. Unity is component-based. I'm trying to do components, but I'm doing it in the worst possible way. So I basically scrapped all this after a discussion with some of my coworkers and started again on this part. You can all have a moment to recover from that because we've got one more to go. So we've got the inheritance hierarchy here for the creatures. We've still got iHero in there. Deal with that later. And we've got our persistent effects and status effects. I had decided that rather than trying to simulate packed effects and status effects, that I would move any of their UI code and game state code out of there and up into the manager. And then I would only have to simulate the manager, and that would hugely reduce the complexity of what I was trying to do here. So let's see. Yeah, so we've got a persistent effect list. That's really just a bit of boilerplate code that manages reactions that happen to effects being added and subtracted from a list. So don't worry about that too much. It's still a template class, but it's pretty lightweight. So we've got the two specific implementations of that, the packed effect one and the status effect one. We're going to deal with packed effects first because they're a bit simpler, and it sort of shows where I'm going with this. So we've got a base hero packed manager. The base hero packed manager has a list of packed effects, sure. And then we've got the sim and the real subclasses of that that a sim hero and a hero have respectively. So that's quite nice. That's fine, right? But that's way less complicated than the other side of it. So creatures, tiles, and perils will all have a status effect manager. Not templated anymore. This is just a generic thing that contains what would have been the base class code in the inheritance system. A status effect manager has an iStatus effect manager. I'm sorry about the naming. I sort of really ran out of names for some of these things. But the idea is that that is what contains the specific implementation details. It's a component. It's actually sort of like dependency injection, I think, if I'm understanding dependency injection correctly. A creature and a tile and a peril will all create the status effect manager and pass in the specific implementation of the interface that it should use. So all iStatus effect managers will have a list of status effects, just like the packed manager has a list of packed effects. Then there's the tile and peril ones. That's fine because we're not simulating those. We don't care about them as much. Base creature status effect manager has sim and real versions, and they all implement the iStatus effect manager interface. And like you can see intuitively that's a lot nicer than this. But I want to talk for a bit about what I realized about why it's so much nicer. And this ties back into why I made the inheritance arrows red. Look how much red is on this slide. There's not much red, right? We've identified that inheritance is the problem here. It's not much red. Here, there's lots of red. Red is bad. Red is hard to simulate. Red is hard to understand. And so a solution that has less red is obviously better. I have more notes about this that I have to get to on my phone because I've forgotten what I was going to say. But it's going to take forever. No, that's fine. I'll just remember. It's fine. So by this point, I was pretty happy with this. I was happy to leave this in the past and forget about it until I had to write about it for the talk and proceed with this using components. But the side effect of this is that the problem that I've just solved here might sound familiar in that I was trying to share code between a deep inheritance hierarchy, and that's exactly what's going on with Hero, with iHero. So you can totally imagine that creatures in Armello, instead of being inheritance-based, could also be component-based. Just have a base hero with a hero and sim hero. Now there's no problem with sharing any of this code, just have an entity at the core. And then if we wanted to, we could even extend it to those NPCs that we've been ignoring for so long, just because it was simpler not to deal with them. But if we ever wanted to, if we've decided that was important, now we could. I don't think I'd ever go this far for Armello. I think it's a bit too far down that road. I'm much more likely just to turn hero into a component and leave it at that and just solve that one problem, because that's the only problem there is. But this lesson is very valuable for the next game. I think we're all sick of inheritance at this point at League of Geeks, and why don't we lean into what Unity does best and use components for everything? So the next one, understanding strange behavior or debugging. Definitely some bugs in his code at some point, I think. So the reasons that it would be hard to understand. Lots of complex systems being boiled down to a single score. If you look at a score at the end and you have no idea how that score was constructed, then you can't really debug what was wrong with it. Multiple action types to consider. It's not just movement. We're not just doing regular pathfinding. There's card play, there's combats, there's all kind of things involved as well. The best action is not always obvious. If it was obvious what the best thing to do was, it wouldn't be much of a strategy game. And so the AI have to be smarter than me to see options that I wouldn't have considered. So I can't just look at them and say, oh, they should have done that and make them do that. It's got to be designer friendly. So that obviously means it has to be understandable for the personalities. And so I decided pretty early that debug tools would be very, very important. I would want to be able to view the score breakdown. That's the core of everything. If the score is the whole thing that drives the system, then I need to know how it's calculated. I want to be able to force the AI to calculate a path to a specific tile, rather than just like watching them and waiting for them to make a path through a specific set of tiles that I wanted naturally. And I'm a visual person. I want to be able to see the path that they've calculated overlaid over the map using Unity gizmos. So what I came up with on my first pass was something like this, which that has come out pretty small. But that big label there is a breakdown of the score calculation after every move. You can see the green line, hopefully, that goes through the tiles. That's the path that Sana, our bear hero, has decided to take. There are some graphs above there, which a bit of a legacy actually left over from some debug tools that Justin left me very graciously. That was very helpful in getting some of this stuff set up. And so that's pretty good. I can see why she decided to go that way through the settlement to get to the path that I told her to go to. But I mean, as when you implement something, you realize what the problems are. And I can only see the path that she chose. I can't see anything else she considered. So if I disagreed with that path, I wouldn't be able to tell why she didn't do another one. The labels are out of control. When I first did them, they were a lot smaller than that. The more systems that I simulate, the bigger the labels get. And it gets even worse if they're pathing vertically because the labels all overlap. And there's nowhere there to display information about the cards that she wants to play out of her hand. So I did a second pass, added a lot of debug UI, and came up with something like this. Obviously the ugliest thing in the world, but on the left here, we have a list of all the different paths that she considered, and you can click on those to view them in the world with the 3D gizmos. Next to the path number is the score of the path, so it's all sorted by score, so you can see that at a glance. On the right-hand side, if you can look in the very top corner, there's an entry for every node in the path. So I can click on that and see what would be in this label in the middle here in that nicer box. It's a bit easier to read. And even more importantly, you can notice the labels are a lot shorter because I started doing a change comparison on the lists instead of printing the whole thing, just displaying what's changed, which is much more useful when you've got so many things. Like, you're not going to change your magic when you just move on to an empty tile or something. So that's a lot better, but there are still some problems. Oh wait, hang on. I've got to talk about cards first. So for card play, there's a second mode you can toggle to on the left-hand side here. This is really hard for people to see probably, or hard for me to see at least. There's a list of her cards in the top left where the paths used to be. When you click on a card, you can see all the different targets that she considered playing it to, including herself, at all different points on the map. You might remember earlier I said that a big problem with the system was that movement and card play were completely separate. So this is a step towards moving them together. She doesn't just consider the cards that she wants to play and who to play it to, but she considers where she wants to play it from as well. There are some cards in the game that deal more damage when you're closer to your target, for example, and in the current system, they would play them at maximum range and deal the minimum damage. And yeah, there's a few other toggles and options for, I can see what the full state was before and after and stuff like that, just in case the change strings get a bit messed up. But now, this is in a pretty good place now. And then finally, to the natural conclusion of that is actually integrating the card play with the movement. So now we do a second pass over the paths to insert the best card options from that other list. And this is very hard to see, definitely. But in the list of nodes up there now, there's move, move, play card. And you can see maybe a red line. Is this the right slide? Yeah, it is. You probably can't see the red line because of the washed outness, but there's a red line from one of the tiles to the other bear down there because she wants to play a card to him because she decided that's the best place to do that from. So that's really the foundation of what I wanted to do with integrating those two things together and with some really powerful debug tools to see why they're doing it. There's still a couple of problems that I haven't solved yet. The solution we've got here is fine for the debug force pathing that I'm doing at the moment, but it doesn't solve our original case of if we see them do something dumb, we want to know why they did it retroactively. And so I'm going to have to cache the previous turn's paths as well, maybe a couple turns back, to see to be able to view them in the same way. I'm going to need more debug UI. It's going to take some more time, but it'll be worth it for playtesting. And that's all work in progress. So for the designers, the old system had lots of tweakable values on the hero config. Some were for gameplay and some were for personality, and it was not always clear which were which. Some should never be touched by designers because it just breaks their decision-making entirely, and it was not always clear which was which. And there were inconsistent ranges and operations being applied to them. It wasn't clear to the designer whether the number should be in the range of 0 to 1 or -1 to 1 or 100 to 1,000 or whatever, and it wasn't clear whether it was being subtracted or added or multiplied or whatever. So it's a bit hard to tell which number to put in to get the desired result. So the new system will still have lots of tweakable values. That's the strength of the system. That's why we have it. The gameplay values will all go on a game config that's separate from the heroes, that is applied game-wide to everyone equally. Determines things like, health is more valuable than gold, for example. You don't want to kill yourself just to get a bit of money. The personality values will all go in the hero config. That will do things like allowing the bear hero Sana that we saw before. She's a bit of a pure person, so she doesn't want to get corrupted. So she can ignore or amplify the value or the negative value of rot, for example. Anything not to be touched by designers just won't be exposed, but that'll be used pretty rarely because most things should be tweakable. And most importantly, they're going to have a consistent range. So at the moment it's 0 to 10. If you set it to 0, then the AI will ignore that score entirely. If it's set to 10, they'll consider it to be 10 times as important as default, and 1 is the middle, obviously. Not the middle, the default. So, and that's going to be enforced with sliders as well, or it is enforced with sliders on the designer side. So it's not a matter of understandability, it's a matter of forcing them to do the right thing, which I've always found to be more effective than suggesting it. Yeah, that. So the final one, is this the final one? I think so, speed. The speed of the thing was a concern as well. So I don't like threads. Threads are hard, threads are complicated. And I think that often, even I'm tempted to use them as a crutch. I'm like, when I was first thinking about this, I was like, that's fine, I'll just put it on thread. But if you're doing work that can be easily compartmentalized and split into blocks, then coroutines are far simpler, far easier to do, and going to have far less side effects. So that's what I've decided to do until the point where I'm proved otherwise. Make sure you compile out all your debug code. There's lots of heavy string formatting, especially in the debug stuff that I've written. So making sure that was structured in a way that it can be easily if-def'd out was super important to making sure we keep the speed up in final builds. Memory management. As you probably know, C# is a garbage collected language. My first solution to the branching path thing was to clone each sim creature, apply the changes to the new one, and then compare the score difference between those, and then just discard them when I'm done with them. And that triggered the garbage collector a lot. It was not good. So at about the same time as I was improving the debug tools, I implemented that changes thing where we only store the changes for a given action instead of the whole state, and then you can just revert and apply those changes to get back to where you were before the action was taken. Using that same system, I was able to implement some very aggressive caching. So the first time you move on to a tile of a given type, we cache the effect of it, and then we know that tile, unless it has some extenuating factor on it, is always going to do the same thing. You're always going to lose an action point if you move on to an empty plains, for example. So rather than simulating the whole thing again, we just apply that change that we've cached and Bob's your uncle or whatever. Cards can do the same thing, but they're marked as cacheable or not by designers. So for example, the card that deals more damage when you're closer to your opponent won't be cached because we can't just apply the same change every time. But that saves a lot of time as well. The big problem with caching is when to invalidate it. It's always a trade-off of speed of simulation versus accuracy of simulation. I haven't done much of the invalidation yet, so it's a bit inaccurate, but that will be a problem that I'll tackle towards the end of the feature when it's more feature complete. Parallel planning is the other thing that is the big thing that I haven't done yet, which is, so at the moment they do all their planning at the start of their turn, which is way too slow. They can't do it in a single frame anymore, and the AI need to be real snappy because there are people who like to play the game quickly. So instead, they're going to do their planning in the background while other people are taking their turn. They'll always have an idea of their ideal path, and then they will adjust their path based on changes. If someone plays a dangerous card in the way of where I was going to go, then I'll recalculate to get around it, rather than doing everything from scratch every time. And that's still a work in progress, yes. So you may be wondering, are there any good things after all this work? All this, it's taken months, it's caused the code to be more complex. I've scrapped the work like twice. What good has come of this? And the good thing is there are good things. There is actually a benefit to the code structure, believe it or not, after all the inheritance nightmares. So I talked earlier about Armello Engine versus Armello Unity. Armello Engine is gameplay code, and Armello Unity is anything that touches Unity. The original idea behind the split was that if we ever needed to move the code to a different engine, we'd be able to pull out Armello Engine and dunk it in somewhere else, and that would just sort of be plug and play. I don't think it's necessarily super useful for its intended purpose, but it was actually very useful for me understanding what I was doing with the AI simulation. So, for example, tile encounters. That's what handles all the gameplay effects when you move a hero onto a tile. It does, yeah, so there's two classes, there's tile encounter and tile encounter manager. Tile encounter does all the gameplay effects, all the interactions. It responds to direct method calls from the manager. It sends network messages to tell the game when it should progress. And it is gameplay code, it lives in Armello Engine. Then the tile encounter manager starts, manages and finishes tile encounters, responds to the network messages from tile encounter, sends messages, gameplay messages out to any other Armello Unity components such as the UI, and it handles timing, so animations and stuff like that, making sure the game doesn't trip over itself. And it's basically engine code and it lives in Armello Unity. So this was really easy to simulate when I got to it because all I had to do was this. Previously, okay, so tile encounter is a big switch statement, a number of states that it works through one at a time. And then each time it finishes a state, it calls this continue encounter method until either the encounter is succeeded or failed. So all I had to do, and those messages send, those methods send network messages that tell the game to update, so which obviously we can't do in sim code. So all I had to do was rip out those three methods, put them in a variable, have my start encounter method, and then a sim start encounter method that uses different methods that just skip straight to the callback instead of going through the network and therefore not updating the game state. And we can make sure that the simulated tile encounter resolves in one frame, which is very important when you're trying to get things done quickly. So this is just a very simple example of one of the methods that I replaced. You know, the real method sends a network message saying that we succeeded, and the fake one just skips straight to the onComplete. Sure, very easy. Combat is the other main building block, I guess, after tile encounters. It's got a similar structure. You've got combat.cs and combatmanager.cs, looks familiar. Combat.cs lives in Armello Engine and Combat Manager lives in Armello Unity, so I should be able to apply the same theory to very trivially simulate combats as well. So let's have a look at what combat does, what its responsibilities are. So it sends network messages, so far so good. It also responds to network messages, sure. It handles the timing in the gameplay code, okay. Triggers gameplay effects, that's fine. Is that all? Okay. Combat Manager starts, manages, and finishes a combat instance. Okay, that's fine. There was an assumption you could only have one combat at a time. I'll have to fix that, no worries. Responds to messages from combat, not network messages, gameplay messages. It does gameplay effects for some reason on the Unity side. It also sends network messages as well, and then it does the UI updating. So you can sort of see that this is not quite the same split of responsibilities, and it's not even clear cut. It's not even just that they were distributed differently, it's that they're, some of the same responsibilities are split between the two classes. And so not only does this make my life hard for simulating it, it also completely breaks the whole idea of Armello Engine versus Armello Unity, in that if we wanted to pull all the gameplay code out, we'd have to get some things out of Combat Manager as well as out of Combat. And it does the timing as well, sure. Yeah, I was very confused when I saw this. I was like, why are these so different? These two very similar sets of responsibilities with two very similar classes, why are they structured so differently? It turns out that this one is very, very old. It's one of those legacy pieces of code I was talking about. And tile encounter was written by Jason in like one continuous block and was a system that was well thought out before it started. So, you know, it ended up better. Who knew? So I went through and refactored it to basically be the same split of responsibilities as tile encounter. And then I was able to simulate it. But even more than that, the reason that this is good, like you might be thinking you had to refactor a bunch of code. Why is that good? Like that sounds like a nightmare. And it was because it was really old code. But the code is now way easier to understand. I'd had to work with Combat and Combat Manager before to add new features to Combat. And it was always the part of the code that I dreaded wading into because I knew that I would have a hard time. Combat was set up as a series of network messages and responses instead of a big switch statement with states that you would want to move through. It was, like the gameplay code was split between Manager and Combat, so I didn't ever know quite where to put things. But I never quite knew why Combat was so hard to work with compared to tile encounters. So we've corrected the Armello engine versus Armello Unity split just in case we do ever want to take advantage of that. I've gained a better understanding of why the responsibilities in tile encounter are split the way they are. It's one thing for me to know that tile encounter was well written, but it's another thing entirely for me to understand how it was well written and therefore how to apply that to my own code in the future. So it's just a really good learning experience for me to recognize and see in practice the difference between well-written code and poorly written code. Debug tools are a huge benefit. The first time when I started implementing them, I came at the task blindly. I learned through experimentation which features would be important, how to structure the code, how to make it efficient, and therefore it was slower than it would be if I already knew all these things, obviously. So, and you know, the UI, less said about that, the better, I suppose. But all these learning experiences can be applied to the next project, and I will have a better understanding of how to build a debug system from scratch, not only for AI, but for any number of features that may be complicated enough to warrant something like this. My personal experience. So as a gameplay programmer, writing all this, especially the debug stuff, but also both AI and debug, very, very different experience from gameplay programming. It's very data intensive. It uses different structures, different techniques. It's very processor intensive, which performance is not something that I usually have to deal with very much in the gameplay code. And it really got me out of my comfort zone, which I think is something that's important to do every now and then if you're in a specialized role. You never know, especially in indie dev, what you're going to be asked to do on the next day. So having a real breadth of experience across different kinds of programming is super valuable to me. Extensibility. So approaching this feature from the ground up and saying that everything can be boiled down to a score really makes new features become, they sort of reveal themselves. You don't have to go looking for them. So as an example, we calculate a card score based on like a value of the card itself, based on how likely we are to be able to play it and how good it will be for us to play it to someone. And that sort of revealed automatically a bunch of different features we can do. So we can use that to determine which cards to keep and which cards to get rid of by burning them in combats and perils. You know, if it's got a low score, get rid of it, sure. Previously, this was something that had to be specified by the designers to make sure that, for example, that pure character I was talking about before wouldn't play a corrupted card. We can create an aggregated deck score for card draw. There are 3 different decks in Armello that you can draw from. And again, at the moment, it's a designer-specified thing that says that casters will draw more often from the spell deck. But we can make that automatic by saying that if this hero prefers magic, then these cards are going to be more valuable to them, and therefore the deck score will be higher, and therefore they can draw from that deck more often. We can do quest selection based on card rewards. Again, quests currently are quite random. The current quest system was written after the current AI system, so they pretty much choose their reward randomly. Or I think they might even never take the risky option. But cards are often a reward from quests, and so we can now make that decision as a risk versus reward with much more information. And that's all come out of one feature of adding a score to the cards. Having an extensible system like this is important for a game with a long lifespan. We've been working on this game for 4.5 years now, and we're probably going to be supporting it. It's been out for a year. We're probably going to be supporting it well into next year. So having a system that's easy to understand and easy to add features to is very important, especially if we're still supporting it after beginning work on the next game. Swapping between 2 different code bases is hard enough, let alone having one that's impossible to add things to. So let's look at our goals that we stated at the start and figure out how we did against them. So if you forgot these were the goals, I'll go through them one by one and say how I think I went, a bit of a self-review, if you will. Have we maintained the hero personality? Well, currently we haven't given this tool to the designers yet, so I'm gonna have to say maybe on that one. I don't know yet. I'm optimistic, but the proof will be in the pudding as to whether the designers come back to me and say, hey, we can't actually get the result we want out of this system. Have we reclaimed designer friendliness? Very similar answer. We haven't given it to them yet, so I don't know yet. Again, I'm fairly confident. I think that sliders are way easy to understand if they're, a defined range and I've split all the values up. Like I really feel like I've done everything I can to make this friendly for them, but I'm not going to know for sure until they tell me one way or the other. Have we given the heroes the tools to do smarter card play? The card play stuff that you saw just before with the card being integrated into the movement path is basically the most recent thing that I've done on the feature. It's sort of a proof of concept, but I haven't really tested its limits yet and put in a bunch of the knowledge of how to combo cards together, so I really don't know. 3 for 3 so far, it's going well. This is what happens when you do a talk about a feature that's not done. Have we got automatic coverage of gameplay changes? I'm happy to give that one a tick. One of the benefits, the only benefit probably, of doing the distributed development over the course of 6 months was that I was able to see, as I merged in months of gameplay changes into my AI branch that's just been sitting there for so long, that it wasn't having a big impact on the decisions that I wanted to make. I wasn't having to do a lot of extra work to support those new features. They just sort of slotted in naturally into what I'd done. And so that really eliminated a lot of doubt that I was having about the system when I was seeing that benefit before the system was even done. Can we support difficulty levels? Well, in theory, yes. All we'd have to do is say that the easy AI doesn't always make the best choice, just apply a fudge factor or whatever to the choice out of the list. But realistically, it's not done yet. Who knows? It might not be fun. It might require a lot of extra work to actually make it a satisfying experience to play against easy versus hard AI. And is it easier to debug? I'm going to say yes to that one, as I've been doing a lot of debugging on the system and debugging on the debugging system as well. The tools that I've got there are super powerful, and it's, when I was trying to figure out why the AI weren't playing the cards, when I was trying to implement that card thing, I realized that, okay, sure, they're not valuing health very much, so they don't think it's valuable to heal themselves. So, and I got all that from my score output, right? So already I can see the benefits of that, and there's still work to do on the debug system, but definitely I think it's been a huge, huge benefit. So 2 out of 6. But most importantly, there are no no's there. I think that being optimistic about the 4 maybes is a good sign. So the takeaways for you all, hopefully. Non-contiguous development is hard. You can't always avoid it, but you have to try to mitigate. If you're going to get stuck in a situation like this where you have to do a big feature over a long time, if you can't convince your producers that that is a really bad idea, then you're going to have to do some things to mitigate it. Doing sprint planning or something similar to that is a good way to mitigate it. Instead of just saying, yeah, cool, give me 2 months to do AI and that'll be fine, you're forced to, by the sprint process, to make individual cards for each task to a point where your team members are confident that they can estimate how long they think it'll take for you. And therefore, it really, you'll still miss things, but you'll be a lot closer than you would be if you just had this one overarching task that you assigned 2 months to. Simulating gameplay can be effective, but it makes your code harder to read. It's a lot of work if your code base is not designed for it, and it's slow, and it requires creative solutions to that. So it's definitely not the solution for everything. I feel confident that it's the right way to go for Armello because it's such a strategy-heavy game with so many intertwining systems, and that we do want to support a good single-player experience. But it's been a significant investment, and it's not always the right choice. Also, in terms of the speed thing, being creative is much better than throwing power at it, in my opinion. I could have just put threads on the AI code to make it faster, but the change, implementing the change model instead of the full simulation model, unlocked a bunch of potential for me in terms of saving speed, in terms of making debug features that were stronger, and putting the planning in the background is going to be a huge gain as well in terms of having the AI always have an active knowledge of their path can be used by a lot of different things as well. Like if I know where the other AI are going, I can try to play things in their way. Components are better than inheritance. That goes against everything else taught at university, but more and more I'm learning that everything I learned at university was wrong, so maybe that's on theme. Components scale better. They are more resilient to changes to your code base. You're not going to have to rewrite everything if it's based on components just because your inheritance hierarchy changes. It's, obviously better for simulatable stuff. It's just, I'm a complete convert to components. I was skeptical for a long time, and I'm a complete convert. Debug tools are incredibly important. I don't think you can spend enough time on debug tools. My producers probably disagree with me. I don't think any of them are here, thankfully. But every hour that I've put into debug tools has repaid itself already. And I will put in more hours, and it will bring more benefit. And simulatable code is good code, even if you don't actually simulate it. If you write your code with the intention that you may simulate it at some point in the future, then it forces you to really think about the split of responsibilities. It forces you to really think about the structure, and it forces you to really be picky about what you write. Instead of, it can be hard if you're like just prototyping something, but and I don't think it's necessarily the right way to write code. It's not something that I'd recommend for every code base or every project, but it's definitely something that I'm going to keep in mind when we start on the next project and are building, a new code base from scratch. So there are a couple of outstanding questions from this. I don't quite know how I'm going to solve the multiplayer problem yet. You might remember that I said about the rotating authority system. Currently, the authority is who controls the AI. But if the AI are doing their planning at all the time during everyone's turns, it's going to be a bit of a challenge to get the correct player to have the correct knowledge of the correct AI at the correct time. And I'm going to be probably working with our network programmer to figure out the best solution to that. And then also the next game. There's no guarantee the next game will be a turn-based, state-based strategy game. If it's not, I don't know yet how applicable much of this will be. I don't know if it can be applied to a real-time game necessarily, but those are some questions that I'm excited to answer. And so with that, we have a very short amount of time for any of your own outstanding questions, if you have any. Thank you for coming. And yeah, does anyone have any questions for me? Yes?
I have 3 questions. I'll try to remember them all. First of all, Armello has cards and dice. Are you doing any random simulations, or are they deterministic? Second question, is the AI simulating for themselves only, or are they also simulating your opponent's moves? How many turns do you simulate? 1 or more?
Okay, so for the dice thing, when we simulate combats, I currently run 50 simulations on a combat using just a random number generator to get an average spread, because there's a lot of stuff. I was going to try and do a deterministic thing, but it's a bit hard with all the number of mechanics that interact there. For the third question, which was about, no, I forget them both already, sorry. Cards.
Concerning only themselves or
yes. Only with themselves at the moment, but I think I'll probably let them look into the other AI players' paths a little bit because you can sort of have an idea of where they might be going, just to do some planning around playing cards in their way. And then the third one was how many turns do I do? At the moment, I'm planning to their meta goal tile, which could be anywhere from 1 to 3 turns away. I may have to limit that back because it's pretty slow if you do a long path. So I'm probably going to do something where I do like a quick pass over the full path and then a more precise path over just 1 turn worth of values. Yeah. Yes?
I'm a long-term listener, first and foremost. With the improvements that you're making to the AI, have you considered how that will affect the existing difficulty of the game? And are you considering something like fuzziness into the scores? Yeah,
so I definitely think that we won't just be able to pick the first value out of every list. I think that'll probably be too hard if I've done my job right. So the difficulty levels thing I was talking about, I will definitely be applying some fuzz value to get to the base game. And then it'll just be a matter of tuning to make sure that it still feels right. Yeah. Does that answer your question? Yeah, cool. All right, I think we're out of time. So if you have any more questions, I'll be hanging around outside for a bit. You can also hit me up on Twitter. Happy to answer any questions you might have. Thanks for coming, everyone.